Okay, Bismillah ar-Rahman ar-Rahim. Let's do this problem, chapter 4, part 2. What is the moment of that force, of this force, which is minus 240I plus 320J plus 300K Newton, this force from the axis OB, from the axis O, from here, OB. Okay, let me erase all of this. And I need the moment around the axis OP. This is a little bit different from the one we just did before, the moment around the point. Here, we need to find out the unit vector OP, and of course the force is given, and we need to find out any point. Let's say the easiest point is to take from point A, let's just put it in red, from point A to the tail of the force, okay, and that is the position vector ROA. Remember, if you want to find out the moment around an axis, we need to find out the unit vector of that axis. So what is the point O? The coordinate 0, 0, 0 meter. Okay, now we need to find out the next one. It is the point B, which is the point where we're going to be taking the position vector at. Let me just erase this so I can see B. Okay. So the point B, it is at this point, and that is higher in the Z, 3 in the Z, and then 2 in the Y, and this is 0 in the X. So P, it is 0 in the 0 in the X, 2 in the Y, and up higher 3 in the Z, and that is OP. So we need to find out the position vector OB, B minus O, 2J plus 3K, and that is in meter. We need to find out the magnitude of OP, square root of 2 square, 3 square, 9, plus 4 is square root of 13. So we found out the unit vector of OP. This is the first one. 2 over square root of 13J, this is in meter, plus 3 over square root of 13K, and of course unit vector has no units. So we have unit vector OB, and that's the first one. Now when we find out the moment around OP, moment around the axis OP, that you cannot put a vector here because the answer is scalar. So this would give you the unit vector OB dot the position vector that we took, which is from O to the tail, and that's going to be ROA. And then we cross the force. That's how to find the moment around the axis OP. So now we could do it like this. The unit vector, it is 0, 2 over square root of 13, 3 over square root of 13. For the moment around an axis, we don't put the IJK. We put the unit vector at the top, the unit vector of the axis at the top. Down, we're going to put the position vector ROA. Okay, what's point A here? So point A, it is, you can see here, minus 2. The Y, it is still 2. And the height is 3. ROA, which means A minus O. A minus O, ROA, A minus O, which means minus 2I plus 2J plus 3K, and that is in meter. And we're going to put that here, minus 2, 2, 3. And at the end, we're going to put the force, minus 240, 320, 300. Okay, so now we could find this is minus 100. Well, it's 199.7, so if you want to make it three significant figures, so it is minus 200. Of course, Newton meter, we have the magnitude and we have the units, Newton meter. This means 200 Newton meter, and you can say it is clockwise. Okay, because the negative. So now, let's assume that he does not want the magnitude, but he wants this moment in Cartesian format. يبي هالmoment in IJK. ماكو مشكلة. If you want to find this moment around this axis OP in Cartesian format, you multiply the 200, which is the moment in magnitude format, moment around the axis, multiplied by the unit vector OP. Unit vector OB. And that is the same unit vector that the moment is around. So 200 times, what is the unit vector? 2 over square root of 13j plus 3 over square root of 13k. And that is in Newton meter. And that we should put them negative because this is the actuality, and now we're going to have minus 111j minus 200 times 3. This is minus 166k Newton meter. And that's going to be the moment around the axis OP in Cartesian format, and that is the moment around the axis OP in scalar format. Thank you very much. These are the two only things, either a moment around the point, you have to put the determinant, IJK, put the position vector, and put the force down. Or if you want to find the moment around an axis, you have to find the unit vector of that axis, find the position vector of that axis, find the magnitude, divide the position vector over the magnitude to find out the unit vector, and then put the unit vector at the top. Find the position vector from any point on that axis. Remember, for this, I found this point, which is, and this is the same axis OP, 2.A. You could find point B, which is at that axis to A. Whatever way you do, it will give you the same answer. Thank you.